Hello there. Good afternoon, all. Glad to be here. By show of hands, how many of you here are application developers? Okay, that's good. How many of you here use auto ID, sequence type, or identity in production today? Okay. So, how many of you here use an ORM framework like Hibernate? All right. All right. Okay. So, before we get started, are you folks here as in here right now? Because generally post lunch sessions are very tough. That too after a delicious meal, it's very difficult to be awake, right? Okay, let's see how it goes. I'm having a blast so far because I learned a lot of insightful information from all these wonderful talks, from all the wonderful speakers. And we have a lot of interesting sessions lined up for tomorrow as well. I'm looking forward to it. My name is Srini. I'm with Yugabyte, and this talk is on identity crisis through the lens of a developer. Right. The motivation for this talk is if you look at it from the perspective of a database, right? In PostgreSQL, we have quite a number of ways using which we can generate auto ID values for database records, right? For example, sequences, identity, UID, just to name a few, right? But from a database standpoint, for example, if you take sequence versus identity under the hood, the database would treat it more or less the same way with little to no differences at all. But if you look at it from the perspective of a developer, someone who writes code using an ORM framework like Hibernate, the difference may be little, again depending on the usage pattern. Sometimes you won't find any difference at all, but sometimes you find a massive difference, right? So the idea of the talk here is, again, a disclaimer here, so I'm not going to give you any recommendations per se. We'll go through all the different usage patterns. These are all some of the usage patterns that we had come across, thought of putting in front of the community, right? So the idea here is to go through all the different usage patterns, understand the similarities, differences, trade-offs, and the common pitfalls to watch out for, right? So for example, if you know the trade-offs fully well, and if you, with the trade-offs fully understood, if you use a generation type, and you know that these trade-offs are there and you are fine with it, right? Because these different generation types are supported by the database today, and all these different frameworks support it as well, right? And in the end, if time permits, I'll quickly give you a sneak peek of how these auto ID generation types work in a distributed database like Yugabyte DB. All right, just to set the context, in the interest of everyone, we'll start with a brief overview of this identity column types, more from a database standpoint, and then straight away we jump into the common usage patterns, right? We'll go through all these usage patterns, we'll run a little test to understand how the interaction happens between the application layer and the database layer itself, right? So the number of round trip calls, latencies, if you can do some optimizations on the client side or on the server side, and so on and so forth, right? Identity column can be defined in two forms. I've listed out both the forms. The first one is pretty simple. It's one of the most commonly used forms where you define a column type and then serial or big serial, right? And the next one is more verbose. It's very self-explanatory. By looking at the definition itself, you can understand that. So this is the auto ID type, right? The difference between these two forms, more from a database standpoint, is with ID serial under the hood, the database creates a sequence and then changes the column data type to int, depending on what you have defined, serial or big serial. So in big int, and then it binds that sequence number to the serial to the column itself, right? But the other one is more verbose. So there are still little nuances. So if you want to grant access to the table, with the second form, you inherently get usage access for the sequence itself. Whereas with the first form, if you grant access to the table, you have to explicitly grant usage access to the sequence as well. And there are a few other little differences as well. So let's not get into that per se, right? And there is another way that you can define auto ID column in PostgreSQL. So that is using create sequence, right? Here you can define an explicit sequence, and then you can use that sequence as the default auto ID column for a table, right? So for your primary key. And the difference between this form and the previous form is, in the previous form, the sequence is kind of tightly coupled to the table itself, it will be owned by the table. Whereas in this case, the sequence is decoupled, it's external. The same sequence can be used in other tables for other columns as well, right? Let's look at it again, how we would use these different types more from an application standpoint, right? So here we'll look at it more from an ORM tool like Hibernate. In the case of Hibernate, if you want to use an identity type, all you need to do is just annotate your object ID or the property with generation type as identity. This is pretty simple, right? It's very straightforward to get started. It's pretty concise. Someone coming off of MySQL or other database systems obviously tend to use the generation type as identity, right? And I'll talk about the bottom part. So we'll run some experiments to understand what is going on, what does each of the entries signify, right? And if you want to use generation type as sequence, again, this is more verbose. The generation type is generation type sequence. In addition to that, you have to define the sequence name as well. What is the generator name, right? So that's been defined on the database side. Okay. So I have a couple of test cases, basically to understand what is going on. So when we try to, the use cases would be different, right? So you'd be using this more on real-time integration part, or you'd be using it for batch integration and so on and so forth, right? So sometimes you define your primary key with just the sequence ID alone, but sometimes you need to define it with a composite key, right? Let's try to understand how the interaction would happen when you define your key in a certain way, whether it's generation type identity or sequence, more on the application side. Let's try to understand the similarities and differences. Just a second. Okay, I have Postgres running in my local system, and then what I'm going to do now is I have defined a to-do identity column with generation type as identity, and this is a very simple experiment to understand if you persist a record, what would happen, right? So more on the number of round trip calls, latencies, and other stuff, right? So I'm going to run this. I'm going to persist this record. Right, we enable some statistics on the application side itself. So if I look at the numbers here, it says that it has taken T0 time to acquire a JDBC connection, and one JDBC statement has been prepared, and one JDBC statement has been executed. So if you use generation type as identity, it's exactly one statement that gets executed on the database side, right? And if I look at the database log itself, right, at the bottom, it's been printed. The audit statement has been printed. The insert statement has been printed. But if you closely watch that insert statement, in the end, it is returning star, right? So what does it mean? So when the framework submits this object to the underlying persistence system, it does not generate the ID for the generation type identity. If you define the generation type as identity, it does not generate the ID on the client side itself, right? So it has to submit the request to the server side, and the database generates the ID, and then the application needs to ask the database for the generation ID to be returned back, right? So essentially, it's two calls on the database side, because the data gets inserted, and then the same data gets returned. It would be part of the same buffer cache data pages itself, but in terms of round trips between client and server, it's a single round trip, but the number of operations on the database side is 2, right? And if I do the same thing with sequence type, so again I have another domain object, so generation type as sequence here. I'm going to insert that object again, right? So this is again defined with generation type as sequence, and it has executed. And if you look at the stats here, again similar to generation type identity, one JDBC connection has been created, and it has prepared 2 statements, and it has executed 2 statements. So that's the difference between using these 2 different generation types. The reason being, with generation type sequence, the application will send a request to the database beforehand to get the next value of the sequence, and the same value is set in your domain object, and that is again sent back to the database to persist the object, right? So more or less with a single object insert, whether you use generation type identity or sequence, the number of operations on the DB side is same. But in terms of round trips between client and server with generation type sequence, there is one additional DB call to be made, right? So you have to get the sequence beforehand and then set it in the object and then submit the domain object to the database, right? So let's look at it how, I mean, what would be the difference if you do a bulk insert, right? So sometimes let's say a end of day processing file where you get a millions of records and you have to persist all those records in the database, right? So where you want to do a batch inserts or whatnot, right? So let's run the same test case again with identity first, right? So here I've defined my insert size is 10, but essentially you'll use 100 or 1000 based on your requirement or whatnot. Just to keep it simple, I've kept the batch size to be, I mean, I haven't set the batch size yet, but in terms of the number of objects to be persisted, it's been set to 10, right? So with generation type identity, again, it is pretty straightforward because we are inserting 10 objects here. So in one connection, we have to prepare 10 statements and then execute those 10 statements, right? As simple as that. And if I do the same thing with sequence, right. So with sequence, it's 20 JDBC executions, right? Because it has to get the next value beforehand for all 10 objects. So that's the reason you see select next val of the sequence. It has to get all the 10 values and then set it in the domain object and then send the request back to the database. So, I mean, if you look at this way in raw format, you would think that generation type identity is a better option to be used in the application. But from a sequence standpoint, we have room for more optimizations per se, right? For example, in Hibernate, we can set something called batch size, where let's say that if you, instead of sending these records as individual statements back to the database, you can batch it on the client side itself, and then you send it back to the server. So that would cut down the number of round trip calls between the client side and the server side. So what Hibernate does is it will, based on the batch size, it will keep it in the cache and then it will send all those records as one statement back to the database. So I'm setting the batch size here as 10. My iteration loop is also set to be 10, right? So just to be on par with the same value. So if I run the same text, if I run the same group identity flow experiment again, after setting the batch size to be 10, with generation type identity, I don't see any difference here. Even though I've set the batch value to be 10, it still has send 10 requests back to the database, right? So you see all the insert into to do I here, right? So it does not, I mean, whatever the flag that we set, it's not getting reflected here because with generation type identity, the framework simply ignores it because it can't do the optimization on the client side because there is no way for the client to know the identity value beforehand, right? So you have to send the request to the database and then again ask the database for the generated value, and then it needs to be synced back again with the state of the database. Whereas if I run the same test experiment with generation type sequence, earlier the number of round trip calls were 20. Suddenly it has gone down to 10, right? So there are just 10 JDBC statements and one JDBC batch statement, so which is an additional thing. So if you use generation type as sequence, then the client side framework can do that optimization, right? So though it has made 10 requests to get the next value, but these insert statements have been cached on the client side and it is submitted as one request back to the database. So if I go and verify the database log here, database log, it is printed as 10 statements. So in this case, the caching has happened on the client side. Client has buffered all the 10 requests, submitted it as one. But on the database side itself, it's been executed as individual statements, right? So in order to optimize that part, in addition to this property, what we can do is, we can set something called rewrite batch inserts to true. So that's as part of the connection string, you can specify it. So this property would be useful, especially for batch inserts, where you are processing multiple records and need to cache it both on the server side as well as the client side, right, as part of the insertion. So if I go back to the group sequence flow test case, if I run it again, we wouldn't see any difference on the client side, because on the client side it's already being cached, right. So 10 JDBC executions for next val, 10 next vals, and 1 JDBC batches. But on the server side, we see a difference here. So earlier, all the 10 statements were logged as 10 individual insert statements. So that has been actually batched on the server side as well, right. So now all the 10 statements were batched based on the value, whatever we have set, and plus the property rewrite batch inserts to true. So that's the difference between using identity and sequence flow, right. So let's go back to the slide again. So we looked at the bulk insert optimization. So with identity, we will not see any difference. Whereas with, if you use the generation type of sequence on the client side with these two properties set, then you'll see optimizations both on the client side as well as on the server side, right. And let's keep going, right. So in addition to it, so even with this, for inserting 10 records with identity type, there was 10 round trip delays to the database, whereas with sequence type, 10 round trip delays to the database plus 1 additional JDBC insert, right. So even with this optimizations, generation type identity seems to be a better option. But having said that, there is one another optimization that we can do, right. So both on the client side as well as on the server side, right. On the server side, while defining the sequence, we can set this property called cache, right. So what happens with sequence is, we don't set the property cache. If you set the cache value as 1, so every time when you fire a request for next value, it has to atomically increase that value, right. So higher the concurrency, that is going to put a more toll on the database side. So with this value, if you set the cache value as 10, what the database does is, when you send a request for next value, it generates the next 10 values for that specific call and keeps it in memory for the session. So the next time when the same session requests for the next value, it's going to be served off of the memory itself, right, because it has already generated the value and the value is kept in memory itself. So it does not need to go and update the value in the data file system per se, right. So that is an optimization that you can do on the server side, right. And on the client side itself, there is one other property as part of create sequence, where you can specify the increment by value, right. Let's say that you want to have Hibernate to cache the next values for bulk inserts. You can set the increment by value to be 10, right. So if you set the increment by value to be 10, then in the previous case, Hibernate has fired 10 next value requests to the database, right. So if you set the allocation size to be same as the increment by value, then Hibernate will generate the sequence on the client side itself, right. So let's look at the difference first, and then we'll go back to the source code again, right. So this is what I spoke about. If you set the cache value to be 10, and if you open 2 different database sessions, in session 1, if you request for next value, you'll get 1, and the next 10 values will be cached as part of the session itself. Immediately after that, if you open another session and then request for next value, you'll get 11. You'll not get 2, because the first 10 values are already cached for the connected session, right. So this will have, this may not be sequential, because sometimes you might lose some values if this session crashes or you close the session or whatnot, right. So those are all the trade-offs, right. And then if you set increment by 15, what happens is, again, 2 different connections. If you select next value, you get the value as 1, and then in the subsequent session, it's going to be 16, because you are letting the database, you are setting it in such a way that it needs to increment the next value by 15, right. And so is the case. And you can use the combination of both, right. So you can enable the caching per session on the server side as well, and then you can set this increment by X value as part of the sequence definition itself. Let's try to do that, right, and then understand, let's try to do that and see what's the difference in terms of the number of round trip calls, right. Okay, I'm going to set this value to be 10, which is my loop count here, right? So I'm setting it to be 10, and if I go and run the same experiment again, right? Yeah, it's showing maybe I've set in the wrong place. Yeah, that's because, yeah, I have to make one more change in the object itself, which is like based on the increment value. So you have set, we need to set the allocation size to be 10, right? So it needs to be in synchronous with your sequence definition, right? So if the sequence definition is like this, so create sequence, this start from 1 and increment by 10. So 10 is the increment value that you are setting it on the server side, right? And you have to maintain the same value on the client side itself. One way to let the framework know that you can allocate 10 values on the client side itself. So again, it uses two different optimizers, pooled and pooled LO. Again, we can configure those things. It's more about when it fires the next value to the database, it gets the first value, and then it again fires the next value, and then it will get the max value. So in this case, it will be like 1 and 11. So that the framework knows that between 1 and 11, rest of the values can be cached, right? So it does not need to again request the database for the next value, right? So that's the optimization that you get with generation type sequence, right? But this wouldn't work with generation type identity. Right? So after this change, if you look at the number of round trip calls, it has come down drastically, right? So one JDBC statement has been executed and one JDBC batch has been executed, right? So this one JDBC statement is the next val call, right? Select next val, which the framework has to get it from the database. And since the allocation size is set to 10, which is our loop count here, so the rest of the values are populated on the client side itself. So with this setting, the round trip calls with generation type sequence has gone down from 11 to 2, right? And think about the batch size that you set. So in this case, we have set the batch size as 10, but if you set the batch size as 100 or 1000, depending on your requirement. So with generation type identity, you'll have those many number of round trip calls, but with sequence, this would be consistent in line with your batch size setting, right? So that's a difference. That's one of the differences between using generation type identity and sequence, right? So the parameters, whatever we changed in terms of setting the cache value or increment by rewrite batches, those parameters would work only with generation type sequence, not with generation type identity, right? Let's move on. Let's say I have a requirement where we have done all this cache optimization. Let's say that table grows where we have to define a composite key for some reason, partition needs to be defined, we have to use a combination of identity type plus some other column, partition column, and so on and so forth, right? So in this case, it's a combination of ID plus created at, and that's how the tables are partitioned, right? So if I go back and run the same thought experiment with sequence, again, I have defined a composite sequence here. So ID, again, generation type as sequence, and then there is another column which becomes the composite key, right? So that's been defined at the domain level. And then in terms of the execution and all, it remains the same. There is, I mean, it's still 2 JDBC calls, round trip calls to the database, right? So all the settings, whatever we have put in here, everything is still been honored here, even though the primary, we have changed the primary key combination, right? So if I run the same thought experiment with generation type identity, it has failure, which is expected because generation type identity doesn't go well with a composite key, right? There are ways, workarounds where you can address this problem, but the reason why I wanted to show this demo is out of the box it doesn't work, right? So you have to write native query, and you have to set null value first, and then let the database generate the value, and then get the value back in the domain object, right? So those are all some of the limitations if you use generation type as identity, right? So if the domain objects are defined this way, then that is not going to work with generation type identity. And the third form is UID. Again, this is commonly used auto ID generation type, right? Again, you can either set the value by default, let the database generate the value for you using this UID Postgres extension. Another option is ORMs natively support that on the client side as well, right? So if you annotate the ID column with that UID generator, then it gets generated on the client side itself, right? Let's run that and then see. And then see the number of round trip calls, right? So in this case, it has cut down the number of round trip calls by 1, right? So with generation type sequence, we had one JDBC statement and one JDBC batch statement, because the one JDBC statement was the client side has to get the next val from the server side, right? Whereas in this case, the UID is getting generated on the client side itself, so it does not need to make any call to the server per se. And since we have already enabled batching, so it's been able to batch all those 10 records, and it has sent it as one request back to the database, right? So with UID, it's more predictable, because I mean, with this, whatever I have used here, I've used UID generator on the client side, so it's getting generated on the client side itself. Of course, you can use the other form as well, where you can let the database generate the UID for you, right? So let's quickly move on. Let's try to understand how this auto ID types work in a distributed database like Yugabyte DB, right? So how the values get incremented atomically, and how the database ensures that consistency part as well, right? So I'll keep it on a high level. Yugabyte DB is a cloud native, horizontally scalable distributed database, where you create a cluster comprising of multiple nodes, and in each node you'll run a stateless Postgres SQL process, right? So the query layer is horizontally scalable, and it's stateless as well. So from a client standpoint, from an application standpoint, you can connect to any of the nodes in the cluster, and these nodes would be able to do read and write across the cluster as well. And the storage layer is distributed. So when it comes to sequences and these auto ID columns, what we do is we maintain it in a special table called system catalog table. So that is again distributed more from a database standpoint. Again, I'm keeping it on a high level. If you folks want to know more about Yugabyte DB and how we handle it, please feel free to stop by at our booth, right? So it's put in a special system catalog table, and what happens is when you fire a next val request to the database, the data, I mean, it needs to read the value from the system catalog, and then it has to go through all the other constraints that you have defined as part of create sequence, and then the cache value increment by value, I mean increment by whatever the x value that you have set there, and based on that the sequence gets incremented and needs to be persisted, and at the same time the same value needs to be persisted in other instances of the database itself. So under the hood, it forms a quorum for every data shard, and it needs to ensure that the data is consistently replicated to majority of the quorum, right? So compared to a single node Postgres versus a distributed system, there is slightly a little higher latency involved, because instead of writing to a single node, it has to run to, with the replication factor of 3, it has to run at least 2 copies of the data, right? So in order to ensure that strong consistency part, right? So let's run the same experiment with distributed database with Yugabyte DB here, right? I'm switching the profile back to Yugabyte here, and if I go and run the same experiment, right. Okay, so in this case, I'm running So far we have seen the loop count to be 10. So in this case, I have set the loop count to be 100 or 105 to be precise, right? The reason being, by default, when you create a sequence in Yugabyte DB, we set the cache value to be 100, right? So we spoke about the next val overhead on the database side, right? So whenever you send a next val, it needs to be updated atomically, right? So when you have higher concurrency, that's going to put more toll on the database. And with Yugabyte DB, the data needs to be replicated to more than one copy, right? So then again, that is going to contribute a slightly higher latency, right? So in order to avoid that, by default, we'll set the cache value to be 100. So that means that when the first session queries the database, generates 100 consecutive values, and those values are kept in the session itself, right? And I have printed the raw explain plan here, right? So just to understand the difference, right? So if you look at the execution time, so for almost for any value that you take, for iteration 97, the execution time was 0.5 milliseconds, and for 98 it was 0.5 milliseconds, 99 roughly in the range, 100 it was 0.448 milliseconds. But if you look at the 101th value, it was 1.2 milliseconds, because since the cache value is set to be 100, it has been able to cache the 100 consecutive values in the memory itself. That's the reason we have seen consistent execution time for the first 100 values, but the next value, again, you have to query the database with next val, so that it will generate the next 100 consecutive values, and that will be kept in memory, right? But in addition to it, the value needs to be replicated to one additional instance as well. So that's the reason you are seeing a slightly higher latency with Yugabyte DB, right? And then in order to keep it predictable, what you can do is you can use UID. That's one other one option, where if you want the latency between client and server to be always predictable, to be consistent at same level. So I'm running the same thought experiment with Yugabyte DB with UID in this case instead of generation type sequence, right? So with this, if you look at the execution time, it's predictably consistent, right? So always around 0.5 to 0.6 milliseconds and so on and so forth, right? So this is one of the options that you can go with a distributed database like Yugabyte DB, right? So to conclude whatever we have looked at, so from a database standpoint, whether it's sequence or identity, under the hood, it's more or less the same with few little differences. Again, the storage size can be 2, 4, or 8, depending on whether it's small int or big int. And from a client's standpoint, you can use these two different generation types, generation type identity and generation type sequence. And sequence is pretty much framework friendly. You can do a ton of optimizations with sequence, whereas with identity, it does not honor any of those optimizations at all, right? So everything is simply ignored, right? And again, UID is another option, which is algorithmically generated, can be generated on the client side or server side. And the latency would be predictable, whether it's a single node Postgres or a distributed system like Yugabyte DB. And the storage size in this case, it's 16 byte, because it's been split into 5 parts of 4, 2, 2, 2, 6. So that's trade-offs with UID. Yeah, that's it. Any questions from anyone? Yeah. Mike, sir.
So this brand set optimization, like patching you told about, it is specific to JDBC, or it can be available in all other frameworks?
I'm not sure about other language frameworks, but as far as Java is concerned, Hibernate supports it. So we have to check. If it's Go, probably Go or might have that feature as well. Other languages as well. Yeah, should be there. I'm not sure. Yeah.
Thanks.
Yeah.
Any other questions?
There has been a new kid on the block, ULID. Have you heard of it?
No.
So.
Go on.
So what have you tested it out?
No,
tried it out?
Not for this. Not for this.
Okay.
Any last questions? Okay.
All right.
I think.
Thanks, everyone. Yeah.
Thank you, Srini.